Alright, what's going on, guys? This video we're going to talk about multi-object builder pattern and builder patterns in general. So I went ahead and created these two examples to give you guys an idea of what kind of classes are good candidates for builders and what kind of classes are bad candidates, meaning you should not be creating a builder pattern or factory pattern around these classes. Builders and factories are often interchangeable. So we're going to focus on, I'm just going to call them builders in this context. So what do we have here? We have a class called good example. And then this class is a perfect candidate. It's the most perfect candidate for a builder pattern. And we have a bad example, which is a terrible candidate for a builder pattern, which is actually not, which you should not be using at all. So why is it that the good example a good candidate? Well, I'll tell you. It's because, see, it has 6 dependencies, meaning 6 variables. In the constructor, all of them are being sent in, but technically speaking, it does not rely on what you send in the constructor. If you look at these dependencies, object dependencies here, let me correct these. Technically speaking, you should send all these object dependencies could be nulls. And what the code does is that if it is indeed null, it just initializes itself. So these 3 dependencies are technically never null, regardless of what you send. And same with the booleans, because as you know, in Java, booleans are by default false. So unless you particularly send false here, true here, they will be false. So technically speaking, you don't need to send anything here at all. Same here. So none of these dependencies are required to be sent inside a constructor. And that makes it a perfect candidate for builder pattern. And why is that? Because, so if you look at these examples, they both have the exact same pattern. Meaning flag 2 is true, dependency 1 and 3 are being sent, and then nothing else. So they behave exactly in the exact same way. The only difference is this class here, this line here, is a lot more code to write than this one. Well, actually, in this particular example, it might not be that apparent, but try adding a couple more dependencies here that behave the same way, and then your constructor here will keep growing and growing and growing. But this one here will not, because even if I add 6 more dependencies here, if my only goal is to, in this particular case, set flag 2, dependency 1, dependency 3, these 3 lines will be all I ever need. But without a builder pattern, every time I create a good example class instance, I will have to still send in all the other dependencies. That's why it's beneficial. So let's look at the bad example here. This is my bad example class. It has a card class, which I also created here as an example. Well, let's start with the card class. What is a card class, right? So it accepts a string instance and it holds an instance to it. That's it. And the bad example class has an instance to a card, and then in the constructor it accepts the first name and the last name, and then sets the full name on the card object that you pass into, and then so basically the full name in the card becomes your first name plus space in between and a last name. And let me tell you why this is a bad example for builder pattern, because you have a strict and direct dependency on the card object, right? So you have to send the card object because your code assumes that the card object is being sent. Otherwise, your constructor will throw a null pointer exception. And for this exact reason, this is a bad candidate for a builder pattern. Because what the builder pattern does is that it basically separates all dependencies into their own methods. So you can set them by one by one. And then when you call the build function, you get an instance to it with those dependencies that you set prior. But in this case, let's say I set the first name and the last name, but I did not set the card. Because card is not an optional dependency, this, if you call build, this will call a null pointer exception. as you can see here. So I set the first name and the last name, but I don't set the card. This will create a null pointer exception because your code will try to call a set full name method on the card object that you aren't sending in. So it's going to raise a null pointer exception. So this is exactly why this is a terrible candidate, because your code needs to be basically you're creating an API, and your API needs to be robust. And the first step is in creating a robust API is making it less error prone or not error prone at all. But in this particular case, since your API is not forcing your developer to call a set card method, if your developer does not call a set card method, that is going to create null pointer exception. So you might think, hey, it's not, if the developer doesn't set the card, it's not my fault. It's a logic error on the developer side. No, it's not, because you created that direct dependency to the card. So it is your duty to ensure that you get a non-null instance of a card object in your constructor. Here, if I don't set dependency 1, I know for a fact, I mean, if the user wants to set the dependency 1, but if they forget, it's a logic error on their end because they forgot to set it. Your code behavior will not change because they forgot to set that dependency. But in this particular case, if they don't set the card object, your code will crash. And that is your fault because you're not handling it. You can either handle a null issue on your code, meaning do what you do here. If you want to support dependency creation inside your constructor, you can either create a non-null instance of the card object in your code, or you have to force the developer to pass in a card object. So clearly, a builder pattern here is not necessarily what you're looking for. So just wanted to go over this real quick, but then we're going to move forward to the main topic of this video, which is multi-object builder pattern. But if you have any questions about this, what we covered so far, go ahead and leave them in the comments, and then I'll try to answer them as much as I can. So I'm not going to delete these, but I will comment them out for now. And so when I upload them to my GitHub repository, you guys can still access them in case you guys want to go over them later. So let's talk about multi-object builder pattern. So what is a multi-object builder pattern? Well, it's something, well, I just came up with the name. I don't think it's called multi-object builder pattern. It's basically using a builder pattern to create multiple objects of the same type. That's very important. They have to be the same type, but not necessarily the same, meaning you could have, they can inherit from the same type of object, but they don't need to be the same type of object. I'll show you how we can achieve that. So let's create a package here. Launchpool builder. Okay. All right. So what do we need? We need 2 or more object types, and then we want them to inherit from the same type of object. Well, let's just use 2 for now. So we're gonna create 2 objects. They're gonna be of the same kind, meaning they have the same parent object type. And then we're gonna create one builder that's gonna allow us to build those 2, either one of those objects, in a very robust, meaning it's not gonna have any errors like we discussed here in bad example. It's gonna be a very strong API with no null pointer exceptions, and it's gonna very nicely allow us to create those 2 object types. And the important thing to note here, yes, they'll extend from the same base parent type, but they will have additional behavior because obviously they're 2 different objects and they're unique. They'll have their unique behaviors as well as their commonalities. So we want our builder pattern to support these behaviors. And how do we achieve that? Well, let's just go ahead and create our objects first. So for base object, let's use vehicle, right? And then we're gonna have like an SUV and a car, I guess. So vehicle, you have a car. Okay, so first let's determine what we want our vehicle to have. So what does a vehicle have? It'll have make, the brand, model, and then we'll have a year. Alright, so all vehicles have these three dependencies. And then our car object, we'll put stamp on it. Okay. And so will the SUV. Okay. So like I said, SUVs and cars will have different behaviors. Or dependencies for them. Boolean, let's say, is four-wheel drive. That means four-wheel drive, in case you didn't know. So that this Boolean will determine whether our SUV is a four-wheel drive or not. Then call it. We'll have an enum here. Let's do an enum. Enum size and L. I guess that will be the size of our SUV. Some SUVs are large, some aren't. Doesn't matter what it is. Okay, then this should be enough. Doesn't really matter. And then car has, let's add it. Go back here. Automatic. Now I'm aware that an SUV can be automatic also. Just forget about that for now. Let's assume that only cars can be automatic. Then again, let's create another enum. Fuel type. Yeah, sounds good to me. Electric, gas, diesel. Okay. All right. Again, I'm aware that fuel type can be set on the SUV also. Let's assume that these are different, okay? All right. So what I want is to have a builder pattern inside the vehicle class, which is abstract, meaning you can't initialize the vehicle object on its own. But our vehicle class will initialize through a builder either a car object or an SUV object. And I'll show you how we can do that. So what are we going to do here? In our car object, we're going to create an interface that's going to be package private, because we only want to access the interface inside the car object. I mean, inside the vehicle object, which is in the same package. So there's no reason this should be public. In our interface, we're going to call it car builder. Okay. And it's going to accept generic, and you'll see why in a few minutes here. And then we'll return that generic. Set is automatic. Okay, and then again we'll return a T, and this time we set fuel type. Okay, and we're going to do the same exact thing inside SUV. Okay, so I did the exact same thing here on SUV. I just created a builder interface, that basically sets just these two variables and accepts a generic type and returns that generic type in every single one of these methods. I also went ahead and changed this from all caps to like a regular casing. Did the same thing in the car object. Fuel type is no longer just all caps fuel. Fuel type just a regular class declaration type stuff. And then yeah, that's what we have so far. And then why we are doing this will make sense in a minute. So let's go back to the vehicle first. Add the base constructor for the vehicle. I also went ahead and added this base vehicle builder interface to the vehicle to cover these variables here. And I'm going to add a constructor here. Alright, so I've done a couple things here. We'll add all constructors required. I added a car constructor here, an SUV constructor here, and the base constructor, which is protected to our vehicle abstract class. I also made this size public because you need to be publicly passing this in. So these two field type and the size enums should be public. So alright, so let's go back to our vehicle class, which is where the builder is going to exist. Guys, so I forgot to add one last thing, well, a couple things. So all the builders that we have, well, just two right now, car and SUV, need to have a build function, build method that returns the actual car object, right? So we need to add this here. Build. I'm going to name it build car. You'll see why the naming is important here. And I'm going to add here SUV build. Alright. Okay, so we need to do a couple of things, very minor, for our main builder here. Create it's kind of like a wrapper interface, but it's not really a wrapper, you see. So it's going to be an interface. We call car builder. It's going to implement extend car builder of this type. Okay. So I'm going to do the exact same thing for SUV. SUV. It's going to extend SUV builder of SUV builder type. Alright, so we're actually done. Now we need to create our actual builder. So let's see. It just needs to be a public class. Obviously, you need public access. It's going to implement. So it's going to implement basically our base vehicle builder, which is going to have a generic type of vehicle builder itself. It's going to have car builder, CV builder. Okay. Implement all methods. Perfect. So let's add our variables one by one. It obviously needs all these, so I'm just going to copy paste this here. Copy, paste. So I'm going to go back to our car. I'm going to copy these. I'm going to paste them here. Same thing for the SUV class. Copy these. Paste. So I just quickly realized I made one mistake that I've covered before. Here, I mean, the automatic type is the Boolean type, so you don't necessarily set it. But fuel type, if not set, should have a default value, I think. In this particular case, if it is null, it should be gas, I would say, right? Because that's the most common one. So if it's not null, then fuel type. We do the same thing for SUV. If the size is null, then it's going to be a medium. If it's not null, then it'll be size. Okay, going back to our vehicle, you have all of our variables here. So now let's start actually populating them. So set is automatic. So return this is automatic. Also, let's do this first. They all are the same. They're all going to return this. That one. And you'll see why this technically is like super strong, and there's nothing really wrong with this type of build behavior. Fuel type, turn new car, make model new, use automatic, fuel type. Is four-wheel drive. Set the size. Make model year is four-wheel drive. Set. All right. Oh, not done yet. Make this model I might just go ahead and fast forward these and then show you guys the very end because this is all just minor stuff. Alright, so our build is pretty much, it's actually done. Now we have everything we need in place. And so let's go over it real quick. So now we have a vehicle builder, which is technically a single builder type. But because of the way classes are set, is that as long as you're setting these, you basically get to set stuff that's on a vehicle builder. And these are basically common to both our SUV and a car, so you can set them. And because they return a type that's vehicle builder of this, you will still have access to all these other interface methods. But the moment you pick set fuel type or set is automatic, or basically any other method that belongs to either SUV or the car, they're going to start returning not the base builder type, but their own interfaces. In this case, it's the SUV builder or the car builder. And when that happens, you're basically stuck with one type or the other, which is great because obviously you don't want to set the size on a car value because car doesn't have a size. So once you start setting size, and then you get a return method for the builder of the car type, so you can no longer build an SUV because you chose to go down that path. So let's just see what it looks like in the code itself. All right, so let's go back to our code. Oh my God, I just realized I probably should have zoomed in. Man. I mean, I hope you guys can read this. Anyways, let's just go back here. All right, so let's start. Let's say we have a vehicle. Start off with vehicle. Builder. You have any builder type? Okay. So initially we have access to all of our methods, as you can see here. So once you're setting the common stuff, such as, well, let's start off with the year. The year is, let's say, it's like a brand new car, right? Okay, set make what is it? It's, Mercedes set model. I don't know. That's okay. All right. You can take these are all base vehicle stuff. So once we start setting though, the fuel type, let's say fuel type gas, click. Another issue. So our interface for that particular one needs to be public. So let's just do that. All right, so I made these two public, so I can access them here. So going back here, as you can see, you can either build the car right now, or we can set is automatic. Let's say it is automatic, and build my car. See, I'm using the same builder. So why is we're getting this error? It's not enclosing class. Got it. We're gonna have to make that static. So this has to be static. Yeah, so that's just, oh yeah, that was just error. All right, so now that it's static, so go back here, same thing. So let's just call it a car. I'm going to do the same thing with a SUV vehicle. Oops. All right, so let's set here. This is a little older. Let's say make to the set model for set. Okay, so this is where the difference is, right? So it's the moment I switch to the SUV side, it's four-wheel drive. Let's go true. Now I only have access to those, which is great. Let's go large. Build SUV. See, perfect. And here in the SUV, this is actually should be package private. It's actually perfect if you want all initializers to go through same thing, same class. So you can actually you don't need to expose these necessarily. You can just expose vehicle class as your API source, and then they'll have access to those two classes through the builders. It's actually a pretty clean, pretty good pattern. I mean, obviously this class right now just accepts stuff. There's no getters. If you want, you just easily add getters to your vehicle and your car. So that's something I did not cover, but that's besides the point. Well, hope you guys like this one. I think the next video will be about supplier pattern. Yep. See you guys there. Well, before I finish, I wanted to add a quick reminder in case you run into this issue. So the reason we created these build SUV and build car methods, and the reason they're called build SUV and not build, if they both were the same method name, meaning build, then there would be an interface conflict here in the build methods. So they have to have separate names. They have to have different names. That's why I call this one build SUV, and the build car one is called build car. They can't both be built due to basically type erasure, because yeah, those two methods basically end up having the exact same pattern, and yeah, you can have same method type, same method name, returning two different things. It's just not how Java is designed. Well, I don't think any language can do that, but well, JavaScript can. Never mind. But you get the point. So yeah, make sure your name remains different.